Welcome to a lesson with Dr. Powell. Let's find the area of a pentagon, given that it can be inscribed within a circle of radius 1. So maybe the distance from here to here is 1. Kind of thinking of a circle going around and hitting these guys right here. So kind of the length from here to here is 1, all the way around right here. 1, 1, and so forth all the way around. Now, what is the, well, first of all, if we want to find the area of this pentagon, let's find the area of that triangle. Multiply it by 5, we get the area of the whole thing. So let's take a look at that triangle. We know some things about this. We know that length's 1. We know that length's 1. And we know that this angle right here is 2 pi fifths. Okay, now if we split this in half, and we just look at half the triangle, then this angle right here is actually pi fifths. Now, this right here, the height of this triangle is actually equal to the cosine of pi fifths, which from another video is 1 plus the square root of 5 over 4. Okay, so we're going to use that idea. So that height is precisely that. Well, we're well on our way. We know the height of this triangle. We just got to know the base of it. Now, well, we can use the Pythagorean theorem here since we have this, and this is a right angle, and that's a 1. To compute this, this is going to be the square root of 1 minus this thing squared. Of course, we take this idea, this is just one half the base of this whole triangle. If we simply just double it and then multiply by the height, which is this itself. So this would be like the base of the triangle, and which is the whole thing from here to here actually now. Okay, the whole base multiplied by the height, which is 1 plus root 5 over 4. And then we multiply by a half, we get the area of that triangle. And of course, if we multiply that area by 5, then we'd have the area of the whole pentagon here. So those cancel, and we can work a little bit with this fraction in here as follows. We could take, so let's see, we have 5 times, and then here, let's rewrite that as square root 1. Let's multiply this out. So that would be a 16 down there. And then we have a 1 plus 2 root 5 plus 5. Okay, plus we could think of this as 16 over 16, taking a square root. So we could add fractions, combine denominators, and actually we can take that square root of 16, take a square root of it, it becomes a 4 out here. Then we're just kind of left with this on the inside. 16 plus 1 plus 5 would be what, which would be 22. So we're kind of looking at, and that's multiplied by 1 plus root 5 over 4, right? So it looks like, just simplifying it out a little bit, we get 5 over 16, and yeah, maybe we'll just do that. Let's just do 1 plus root 5, and then we're multiplying this by the square root of, it looks like 22 plus 2 root 5, something bizarre like that. Okay, but at least we did it. Okay, we found the exact area of a pentagon using roots and all of that, based upon our knowledge of what the cosine of pi fifths was exactly. Thanks for watching.